Most people skip a LeetCode video when it feels like a speed run. So in this one, we will not collect random tasks. We will take one pattern, 2 pointers, and actually understand 6 concrete problems well enough to explain them in an interview. 2 pointers usually means one of 3 shapes: opposite ends, same direction, or different speeds. The important part is not the pointers themselves. The important part is the invariant. After every move, we know we did not throw away a possible optimal answer. Before coding, ask 3 questions. What are the candidates? Which candidates can be deleted safely? And what condition tells me which pointer to move? If you can answer these questions, the implementation becomes much less mysterious. The first task is valid palindrome. This is the simplest opposite ends problem. The left pointer and right pointer compare the only 2 characters that can break the palindrome right now. Spaces, punctuation, and casing are just noise, so we skip them. The code is short, but the edge cases matter. The inner loops must stop when the pointers cross, because a string may contain only punctuation. After normalization, one mismatch means false. If all pairs match, the answer is true. 2. Sum 2 works because the array is sorted. Start with the smallest and largest numbers. If their sum is too small, keeping the small number with any smaller right pointer cannot help. So left must move right. The symmetric case is just as important. If the sum is too large, keeping the large number with any larger left pointer cannot help. So right must move left. Each step deletes many impossible pairs, which is why the solution is linear. Container with most water looks different, but it is the same deletion idea. The area depends on width and the shorter wall. When 2 walls are chosen, the taller wall is not the bottleneck. The shorter wall controls the maximum water level, so why move the shorter wall? If we move the taller wall, the width gets smaller, and the limiting height cannot become better because the same shorter wall still limits the container. Only replacing the shorter wall can possibly improve the answer. 3. Sum is the first task that feels harder. The trick is to reduce it to a problem we already solved, sort the array, fix one number, and then find 2 numbers in the suffix, whose sum is the opposite of the fixed number. The annoying part of 3 sum is duplicates. Skip duplicate fixed values, and after you find a valid triplet, move both pointers and skip repeated left and right values. This keeps the output unique without using a set of triplets. Trapping rainwater is the advanced one. The water above an index is limited by the smaller of the best wall on the left and the best wall on the right. A prefix-suffix solution is easier to see, but it uses extra memory. The 2-pointer version compresses that prefix-suffix idea into constant space. Keep left max and right max, move the side with the smaller current height because that side has the limiting boundary that can be finalized now. 2 pointers are not only for arrays. In linked list cycle, the pointers move at different speeds. Slow moves 1 node, fast moves 2 nodes. If there is no cycle, fast reaches null. If there is a cycle, fast eventually catches slow. The code is tiny, but the guard condition is the whole safety check. We can only move fast by 2 steps while both fast and fast next exist. When slow and fast point to the same node, we have proven that a cycle exists. Here is how I would practice for each problem. First, explain the invariant out loud. Then write the pointer movement rule. Only after that, write code. If you cannot explain why a move is safe, you are probably memorizing. The final list is small on purpose. Valid palindrome, 2, sum 2, container with most water, 3 sum, trapping rainwater, and linked list cycle master. These and 2 pointers will stop feeling like a trick